We live in a world orchestrated by electrical circuits. They are the unsung heroes of our modern lives, silently powering everything around us. From the smartphones we hold, to the lights that illuminate our homes, these intricate networks of electrical components are the backbone of our technological age. But have you ever stopped to wonder about the invisible forces that govern these circuits? Just like the laws of gravity govern the motion of planets, there are fundamental laws of physics that dictate the behavior of electricity. Understanding these laws allows us to harness the power of electricity and create the incredible technologies we rely on every day. Join me on a journey as we demystify the fascinating world of electrical circuits and uncover the elegant laws that make them tick. Imagine a river flowing downstream. The amount of water flowing past a point in a given time is like the current in an electrical circuit. The force pushing the water is similar to voltage, and rocks or narrow passages that resist the water's flow are analogous to resistance. This is the essence of Ohm's law, a fundamental principle that describes the relationship between voltage, current, and resistance in an electrical circuit. Simply put, it states that the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to its resistance. Mathematically, this can be expressed as I equals V divided by R. This simple equation has profound implications for understanding and designing electrical circuits. Now imagine a network of interconnected rivers with multiple branches and junctions. Understanding the flow of water in such a complex system requires a different set of rules. This is where Kirchhoff's laws come into play in the realm of electrical circuits. Kirchhoff's current law states that the total current entering a junction in a circuit must equal the total current leaving that junction. Think of it like this: the water flowing into a fork in the river must equal the water flowing out through all the branches. Kirchhoff's voltage law states that the sum of all voltages around any closed loop in a circuit must be zero. Imagine taking a boat ride around a closed loop in our river network. The total change in water level representing voltage throughout the journey will always be zero. These two laws are crucial for analyzing and understanding the behavior of complex electrical circuits. Electricity and magnetism might seem like separate forces, but they are two sides of the same coin. This fundamental relationship is at the heart of electromagnetism, a force that plays a crucial role in how electrical circuits function. One of the key principles is that a moving electric charge creates a magnetic field around it. This is how electromagnets work. Conversely, a changing magnetic field can induce an electric current in a conductor. This principle is what makes generators possible, converting mechanical energy into electrical energy. Section 5. Ohm's law in action, from dimmers to electric stoves. Ohm's law is not just an abstract concept confined to textbooks, it's at work every time you use a dimmer switch or adjust the heat on your electric stove. In a dimmer switch, a variable resistor alters the resistance in the circuit. Increasing the resistance decreases the current flowing to the light bulb, making it dimmer. Similarly, electric stoves use coils of wire with different resistances to control the amount of heat generated. Higher resistance coils produce more heat because more electrical energy is converted into thermal energy. These are just a few examples of how Ohm's law plays a role in our everyday lives. Section 6. Kirchhoff's laws at play powering up your home. Kirchhoff's laws are essential for understanding how electricity is distributed throughout our homes. The electrical wiring in your house is a complex network of circuits connected in parallel. Each appliance or light fixture in your house is like a separate branch in this network. Kirchhoff's current law ensures that the total current entering your house from the power grid is equal to the sum of the currents flowing through all the appliances and lights that are turned on. Kirchhoff's voltage law ensures that each branch of the circuit receives the same voltage from the power source. This is why you can turn on multiple lights or appliances simultaneously without affecting the voltage supplied to each one. Section 7. Electromagnetism in our homes, from motors to speakers. Electromagnetism is the invisible force that powers countless devices in our homes. Electric motors, found in everything from washing machines to electric fans, rely on the interaction between magnetic fields and current-carrying conductors to generate rotational motion. Speakers use the principle of electromagnetic induction to convert electrical signals into audible sound waves. When an alternating current flows through the speaker's coil, it creates a changing magnetic field that interacts with a permanent magnet. This interaction causes the speaker cone to vibrate, producing the sound waves we hear. Section 8. The intertwined world of electricity and magnetism. The more we delve into the world of electrical circuits, the more we realize the interconnected nature of electricity and magnetism. These two forces are inseparable, constantly influencing and shaping each other. Whether it's the flow of electrons through a wire creating a magnetic field, or a changing magnetic field inducing a current, the dance between electricity and magnetism is a fundamental principle governing the behavior of our universe. Section 9. The significance of electrical laws in our modern world. From the simplest circuits to the most sophisticated electronic devices, the laws of physics we've explored govern the flow of electricity. Understanding these laws has allowed us to harness the power of electricity, revolutionizing our world in countless ways. Ohm's law, Kirchhoff's laws, and the principles of electromagnetism are not just abstract concepts confined to textbooks. They are the fundamental principles that underpin our modern technological world. As we continue to innovate and push the boundaries of technology, these laws will continue to guide us, illuminating the path toward a future powered by the wonders of electricity.